Hey everyone, and welcome back. Before we begin here today, please make sure that you like and subscribe because it really does help us out. And it also helps us reach others in need of assistance with these topics. So the topic we'll be covering today is components and resultants, and we are going to use the parallelogram law in order to solve this problem shown on the screen. So what we have here is that we have two structural members B and C that are bolted to bracket A as shown. Knowing that the tension in member B is let me write this down. So knowing that the tension in member B is 6 kilonewtons, so we have 6 kilonewtons here, and that the tension in C is 10 kilonewtons, determine the magnitude and direction of the resultant force acting on the bracket. So we need to determine the resultant force acting between these two, and we need to know its location off of the horizontal here. So we're going to be using the parallelogram law in order to solve this. So using the parallelogram law, you are going to have to redraw this in a free body diagram format. Now, since we are using the parallelogram law, you want to leave yourself plenty of room to draw this figure. The bigger you draw it, the easier it will be to read everything within the parallelogram. So let me draw my XY coordinate system here. So there's my X, there's my Y. My origin point will be the point at which the two forces collide, which is shown right here. So I will have my 10 kilonewtons of force acting up and to the right. And I have my 6 kilonewtons of force acting down and to the right. And then you want to put on your angles that you have for each of these. So if we scroll back up real quick, it is saying that the 10 kilonewtons is 40 degrees off of the horizontal, and the 6 is 15. So we are 40 here, and then we are 15 here. Drawing to scale does help, but it does not have to be a requirement. So that is my free body diagram. Now I am going to work the parallelogram rule or law on my free body diagram here. In order to do that, I am going to have to form a parallelogram. And in order to form this, what you're going to have to do is you're going to have to copy and paste each force. So let's start with the 10 kilonewtons here. We are going to copy this force, and we are going to paste it right here at the end of the 6 kilonewtons. So here is my copied and pasted 10 kilonewtons. And then we are going to copy and paste the 6 kilonewtons and place it at the end of the 10. And it should form a four-sided figure, which if drawn to scale, it would look like a parallelogram. In this case, it kind of looks like a funkified square, but it's good enough for working this process. As I said, the more room you have, the more to scale, it will look better. But this is what we have. Here is our parallelogram. So what is our resultant? Where is it located? Well, your resultant will be from corner to corner, and it will be from where your original two forces act to the corner where your two copied and paste forces collide. So it's going to go from here to here, and that will be my resultant force. Well, we have formed our parallelogram. Now, let's add some more information in here. Well, this total angle right here is 40 plus 15, which is 55. And since we are a parallelogram, the opposite angle has to be the same. So this means that this total angle from the 6 to the 10 is also 55. And since we are a parallelogram, this angle, which we'll just call little c, is also this angle down here. So how do we find our little angle C, our resultant force? What do we do next? Well, looking at our parallelogram, it is a four-sided shape. All four-sided shapes have 360 degrees inside of them. Well, we have these two angles of 55, and we know that this C and this C are exactly the same. So we can solve for that little angle C. So we would have 360 degrees, subtracting off our two angles of 55 degrees, and then dividing by 2 since we have two C angles. So this C angle pops out to be 125 degrees. Well, You can notice here that we have two triangles formed within our parallelogram, which is being split by a resultant. So we have this upper one and we have this lower one. Well, which one do you want to look at? Because it really doesn't matter which one you look at. So I'm just going to look at the bottom one. So let me redraw it real quickly. So I have my resultant force like this. I have my 6 kilonewtons down here. And then I have my 10. Well, it's not really going to be to scale, but let's redraw that, make that a little bit better. There's my resultant force, and then here is my 10 kilonewtons of force here. Well, I just found that this angle right here is 125 degrees. Eventually, I'm going to need this angle right here, which I'm going to call theta, which is right here. And I need theta in order to get my final angle off of the horizontal, my location of my resultant. So what do I do here? Well, anytime that you have two sides known and you have the angle known that is opposite your unknown side, you can use the law of cosines to solve for that unknown side. Pretty much when you're working the parallelogram law here, working through a problem utilizing that method, you're going to have to use the law of cosines and then the law of sines, typically. So utilizing the law of cosines, you may remember that it looks like this. It's side C squared is equal to side A squared plus side B squared minus off 2 times A times B times the cosine of the little angle that is opposite the unknown side of C. That's why we called that little angle C, for instance. So our side C here will be our resultant force. A and B will be the 6 and 10 kilonewtons, and then little angle C will be 125 degrees. One quick note is that a lot of people forget to do this. Since this side is squared over here, in order to solve for the unknown side, you have to square root the entire right side. Easy mistake to make. So let's go ahead and let's fill everything in here. So my resultant is going to be 6 squared plus my other side, which is 10 squared, minus off 2 times 6 times 10 times the cosine of my angle, which is 125 degrees. And then I am going to square root all of that. So once you calculate all that out, we get 14.3 kilonewtons in that general upright direction. So there's my magnitude of my resultant now, which I have is 14.3 kilonewtons. Now, as I mentioned earlier, I am looking for angle alpha, which angle alpha will be a combination of theta and 15, working those two angles to get to alpha. So how do I get theta? Well, we can use the law of sines to get theta. So from the law of sines, this is what it states. We have side A over the sine of the angle opposite that side is equal to side B over the sine of the angle that's opposite that. Well, for this to work, I need a side in the angle opposite and a side in the angle opposite that unknown. Well, I have my resultant that I just found, the angle that's opposite that, and I can use the 10 to find the angle opposite the 10, which is theta, which is what I'm looking for. So scroll down just a little bit here. Filling this in, I am going to have my resultant of 14.3 kilonewtons over the sine of the angle that's opposite it, which is 125 degrees, is equal to 10 kilonewtons over the sine of the angle that's opposite it, which is theta. Well, I can rearrange, cross multiply, rearrange, and solve for theta. Theta is going to be equal to the sine inverse of 10 times the sine of 125 degrees divided by my resultant force of 14.3. And this equals to 34.9 degrees. Keeping in mind, that is the angle from the 6 kilonewtons to the resultant. I'm looking for the resultant off of the x. Well, I know that the 6 kilonewtons is 15 degrees off of the x, so I can find my alpha angle. So my alpha angle, which will be 34.9 degrees for my theta, minus off the 15 degrees, And that gives me a total angle off of the x of 19.9 degrees. So there are my two answers, and it's always best just to draw a quick little picture here showing the resultant and its angle location. So there's my x, there's my y, my origin point. My resultant is going 14.3 kilonewtons in that upright direction, and it is 19.9 degrees off of the horizontal. And that is how you use the parallelogram law in order to find the resultant and its location. So I hope this video was helpful. And if you want to see more problem solved this Friday, please check out the other videos on our channel. Also, if you haven't done so already, please like this video, leave a positive comment below, and subscribe to the channel because all of that really does help us out. Thank you for watching, and I hope you have a fantastic day.